Okay, so hello students. So welcome back to our channel. So in today's class we will see one more problem of quantum mechanics, and it has been asked in CSIR June 2022. So we see the question on screen. So in the question they have asked that Hamiltonian is given to us, and if this is the Hamiltonian, and of course with this Hamiltonian a state is also defined, and the state phi is the eigenstate of this Hamiltonian, then what is the eigenvalue? Very simple question. एक Hamiltonian given है और उसके साथ एक state given है, and they are saying that this state is the eigenstate of Hamiltonian, then what is the eigenvalue correspond to this? So that we can easily do. You see, we know this thing from the postulates of quantum mechanics. We know this thing that if we operate any operator A on state phi, and if we get lambda and phi, if this condition is satisfied, then I can say this lambda is the eigenvalue and phi is the eigenstate. सेम बस यहाँ भी हमें यही करना है. देखिए क्या करेंगे. Very simple. Hamiltonian is given, so instead of A I can put the Hamiltonian, and if we apply this Hamiltonian on phi, let's suppose lambda and phi, or I can put lambda only. So we have to satisfy this equation. We have to use this equation. इस Hamiltonian को अगर आप इस पे अप्लाई करेंगे तो हमें कुछ ऐसा मिलना चाहिए. Then this phi is the eigenstate, and this lambda we want. This we want. So very simple, we can easily do. So we'll do this thing. We will apply Hamiltonian on phi. This Hamiltonian on this phi. Now you see, here we have summation over n. Here we have also summation over n. But both the summations are different. This is the summation on Hamiltonian, and this is the summation on state. Right? So both are different. So what I do, I will choose this n as a m. इसको मैं m से replace कर देता हूँ ताकि आप दोनों में clearly differentiate कर पाएं that which one is n and which one is this n and which one is this n. Right? So मैं क्या करूँगा, just for your simplicity I can replace this n with m. Let's suppose this is m. Right? Now let's try to find out this term. Let's find out this term when we apply h on phi. So what is this term? Summation over n, summation over m. I can put summation over n, summation over m, and then this is complete summation. Now you see, I can write down this term. So this will become, first term you see this into this. So this is E n, this n and this m. N with m and e to the power iota m phi. You see, this n with this m. And this term as it is. Then the second term plus, again I can say summation over n, summation over m, and this is epsilon n plus 1, this n with this m, this n with m, and then e to the power iota m phi as it is. Then last term summation over n, summation over m, right? And this is this term epsilon n, n plus 1 with m, and then e to the power iota m phi. This thing we have. Right? Now see, what is given to us? This is the orthonormal basis. N is the orthonormal basis. So you see, this is nm, nm, n plus 1m. Here I can use the orthogonal condition. वो हम easily use कर सकते हैं यहाँ पे orthogonal condition. तो देखिए ये term कब survive करेगी? The whole summation. When n is equals to m, otherwise it is 0. See, I can put this term only this term I can say delta nm, this I can say delta nm, and this I can say delta n plus 1m. तो ये टर्म कब सर्वाइव करेगी? जब n इज इक्वल टू m होगा। जब n इज इक्वल टू m होगा तो मैं इसे क्या कर सकता हूँ? सिंगल समीशन लिख सकता हूँ। तो दिस h5 will become now summation over n only, single summation now, and this is e to the power iota m5 and this n. So this will become n now. M is equals to n, right? First term. Second term again plus summation over n, this term epsilon e to the power iota n phi, this term, and this is n plus 1 plus, see the third term, this term will survive when m is equals to n plus 1, m is equals to n plus 1. So I can say again summation over n epsilon, now I can put this is m is equals to n plus 1, so e to the power iota n plus 1 phi, and this is n, right? This is our LHS, this LHS, and it is claiming already given है that this phi is the eigenstate of this Hamiltonian, so this must satisfy this equation. तो ये जितना भी टर्म है किसके बराबर आना चाहिए? लैम्बडा phi, right? Lambda you can put as it is, and what is phi? Summation over n, because now हमारा summation n के ऊपर है तो आप m की जगह n लिख सकते हैं. So this is iota n phi n. Now we have to compare this LHS, this complete LHS. This one is LHS and this one is RHS. Now we have to compare this. देखिए कंपेयर करेंगे तो सारी टर्म सेम आ रही है. दिस इज n, दिस इज n, LHS RHS में भी n है. You see this term only, this is n plus 1. We have to take care of this term, क्योंकि इसके साथ तो आप कंपेयर नहीं कर सकते हैं LHS में और RHS में. So what we can do, you see, if you see it carefully, so now what we have, summation over n I can take outside, and this is e to the power iota n phi n plus epsilon e to the power iota n plus 1 n plus epsilon e to the power iota n phi, and this is n plus 1, and this must be equals to summation over n e to the power iota n phi n. This must be equals to this. अब ये टर्म कब इसके इक्वल होगी? आप देखिए यहां भी n है, यहां भी n है, यहां n plus 1 है, राइट? इसको आप चेंज कर सकते हैं. आप इसे ध्यान से देखिए इस टर्म को. लेट सपोज ये n 5 है आपका. इफ n इज इक्वल टू 5 देन n plus 1 इज इक्वल टू 6, यानी यहां जो भी होगा इससे एक ज्यादा है, राइट? तो मैं इसे इस तरह से भी तो लिख सकता हूं. इस n को मैं रिप्लेस कर दूं n minus 1 से और इसे रिप्लेस कर दूं n से. एक ही बात है, n plus 1, or else you can say n minus 1 n. एक ही बात है. So what I do, I will replace this thing. So when you do this thing, this will become e to the power iota n minus 1 n. Now you can take this term common. Now I can write it like this: summation over n e to the power iota n phi, n you can take common, and this will become, this term will become simply e plus, this will become epsilon e to the power iota phi. So this is phi also there, this is phi, plus epsilon e to the power minus iota phi, and this must be equals to summation over n e to the power iota n phi, and sorry, lambda is also there, right? Now you can compare these two terms. This is phi, this is also phi, rest is lambda, जो बचा हुआ वो क्या है, lambda है. So I can say, just write down this. Now I can say that this lambda is e plus epsilon, and this is e to the power iota phi plus e to the power minus iota phi. This is the eigenvalue. Now you see, I can write it like this: divided by 2 and multiply by 2. So this term will become cos phi. So I can say that this lambda is e plus 2 epsilon cos phi. This is the answer. Very simple question. So ये जो क्वेश्चन था इसमें देखिए इंपॉर्टेंट क्या है, द प्रोसेस इज वेरी सिंपल. वी नो कि किस तरह से आइगन वैल्यू निकाल सकते हैं. इंपॉर्टेंट थिंग इज द कैलकुलेशन. जैसे ये टर्म देखिए हमने यहां पे किया, हाउ वी मैनेज दिस थिंग. तो एग्जामिनर यहां आपकी कैलकुलेशन चेक करना चाहता है कि किस तरह से आप इस तरह की प्रॉब्लम को अप्रोच करें, किस तरह से कैलकुलेशन सॉल्व करें. So only thing is in this question is the calculation, rest is very simple. Fine. So I hope now you understand that how to calculate this kind of, how to solve this kind of questions. Fine. So I hope you like this discussion. So if you like the discussion, just write down in the comment section. Also like, share and subscribe our channel. See you in the next video.
अगर आपको ये वीडियो पसंद आया हो तो लाइक, कमेंट, शेयर एंड सब्सक्राइब आवर चैनल.